Friends, this is the part 2 video contains the most frequently or repeatedly asking points. This will definitely help you guys to perform well in the upcoming VSSC ISRO Technical Assistant exam of electronics, which will held on 30th of this month. All the best, friends. First one, average value of a sine wave is 0. Charge of 1 electron equal to 1.6 into 10 raised to minus 19 coulomb. Fourier transform of the unit impulse is 1. Fourier transform of rectangular pulse is sinc pulse, and also Fourier transform of sinc pulse is rectangular pulse. At a resonance, the net impedance is purely resistive. Oscillators use positive feedback. Comparators use no feedback. That is, it operates in open loop mode. Bessel filters are used where the phase characteristic is important. It is well suited for pulse applications. Directivity of an isotropic antenna is 1. System stability is always decided by the location of poles, irrespective of zero's location. For a stable system, poles of the transfer function should be in the left of S-plane. In an RC phase shift oscillator, the phase of the feedback voltage is shifted by 180 degree with the help of 3-stage RC phase network. Single RC network gives the 60 degree phase shift. Hamming distance. It is a metric for comparing two binary strings. While comparing two binary strings of equal length, Hamming distance is the number of bit positions in which two bits are different. Hamming distance can also be calculated by taking XOR of two code words. 13. The basic purpose of a coupling devices are to transfer the AC from the output of one stage to the input of the next stage. To block the DC to pass from the output of one stage to the input of the next stage, which means to isolate the DC conditions. Transformer coupling. In transformer coupling, transformer is used as the coupling element. There is no capacitor used in this method because the transformer itself conveys the AC component directly to the base of the second stage. The secondary winding of the transformer provides a base return path, and hence there is no need for base resistance. This coupling is popular for its efficiency and its impedance matching, and it has the highest gain among all the coupling methods. Boolean algebra laws. Inverse law. In AND form, it is A dot A bar equal to 0, and in OR form, A plus A bar equal to 1. Commutative law. In AND form, it is B dot A equal to A dot B. In OR form, it is B plus A equal to A plus B. Associative law. A dot B dot C equal to A dot B dot C. In OR form, it is A plus B plus C equal to A plus B plus C. Distributive law. In AND form, it is A plus BC equal to A plus B into A plus C. In OR form, it is A dot B plus C equal to A dot B plus A dot C. Absorption law. A dot A plus B equal to A. In OR form, it is A plus A dot B equal to A. De Morgan's law. AB whole bar equal to A bar plus B bar in AND form, and A plus B whole bar equal to A bar into B bar in OR form. Identity law. 1 dot A equal to A in AND form and 0 plus A equal to A in OR form. Null law. 0 dot A equal to 0 in AND form and 1 plus A equal to A in OR form. Idempotent law. A dot A equal to A in AND form and A plus A equal to A in OR form. These laws will help us to reduce the Boolean equations. Theorems and applicability. Superposition theorem, Thevenin theorem, Norton's theorem, maximum power transfer theorem can applicable only in the linear circuits. Telegon theorem can applicable in all circuits. Substitution theorem can applicable in linear and non-linear circuits. Overdamped, that is eta greater than 1, that is damping ratio greater than 1. This is the equation of aperiodic motion, that is the system cannot vibrate due to overdamping. The magnitude of the resultant displacement approaches 0 with time. The overdamped case, critically damped case and underdamped case are shown in the figure. Underdamped condition. Damping ratio less than 1. This resultant motion is oscillatory with decreasing amplitudes having a frequency of omega d. Ultimately, the motion dies down with time. Critical damping ratio equal to 1. The displacement will be approaching 0 in the shortest possible time. 17. For the same symbol rate RS, the data rate for different modulation technique is modulation technique and data rate BPSK, binary phase shift keying 1 by TS equal to 1 RS BPS, quadrature phase shift keying QPSK 2 by TS equal to 2 RS BPS. The data rate of quadrature phase shift keying is twice that of binary phase shift keying for the same symbol rate. Shift register. Shift registers are sequential circuits that are used for storage or for the transfer of binary data. Shift register takes the data present on the input and shift it to the output once every clock cycle. Every shift in the register content to the right by 1 bit position is equivalent to dividing the original number by 2. Every shift in the register content to the left by 1 bit position is equivalent to multiplying the original number by 2. Cascading of odd number of CE amplifier will provide polarity inversion or 180-degree phase shift. Cascading of even number of CE amplifier will provide 360-degree phase shift or same as input. Flash type ADC. It is also called parallel type ADC. It is the fastest ADC among all the ADC types. An n-bit flash type ADC requires 2 raised to n-1 comparators, 2 raised to n resistors and 2 raised to n into n priority encoder. Mode, emitter based biasing and collector based biasing and application. Cutoff mode, emitter based junction and collector based junction are in reverse bias. Application is as off switch. Active mode, emitter based junction is in forward bias and collector based junction is reverse biased. Application is amplifier. Reverse active, emitter based junction is reverse bias and collector based junction is forward bias. Application not much use. Saturation, both emitter based junction and collector based junction is forward bias. Application is on switch. The difference between combinational and sequential circuit. In combinational circuit, the output is determined by the present values of its input only. Sequential circuit, its output is determined by the present input as well as past output values. Combinational circuit, it does not have a memory and feedback path from output to input. In sequential circuit, it has a memory element and a feedback path from output to input. Combinational circuit is simpler, while sequential circuit is complex. Example of combinational circuit is adder, subtractor, demux, multiplexer, decoder, etc. Example of sequential circuit is flip-flops, counters, shift registers. 23. Applications of Hall effect sensors, speed detection, proximity sensing in smartphones, current sensing application, position sensors, example to measure the fuel level in the fuel tank in automobiles, spacecraft propulsion, used as magnetometers to measure magnetic field. When an emitter bypass capacitor present, then while performing AC analysis, the effect of emitter resistance got nullified because in AC analysis the capacitor behaves as short circuit. Effect of removing emitter bypass capacitor, voltage gain decreases, input impedance improves, current gain improves, bandwidth increases. Since gain bandwidth product should be constant, common mode gain decreases, CMRR increases. Triac. A triac is a bidirectional thyristor with 3 terminals. That is, it can conduct in both directions. Its 2 terminals are usually designated as MT1 anode 1, MT2 anode 2 and the gate by G as in thyristor. When in operation, a triac is equivalent to 2 SCRs connected in anti-parallel. As the triac can conduct in both directions, the terms anode and cathodes are not applicable to triac. It is used extensively for the control of power in AC circuit. The figure shows a symbol and the characteristics of triac. MOSFET. MOSFET is a voltage-driven or controlled device. The current through the 2 terminals is controlled by a voltage at the 3rd terminal, that is gate. It has high input impedance. It is a unipolar device. BJT. BJT is a current driven device. The current through the 2 terminals is controlled by a current at the 3rd terminal base. It has a low input impedance. BJT is a bipolar device. Oscillator. The output of oscillator will not depend on input voltage because there is no input voltage for an oscillator. An oscillator is an amplifier circuit with positive feedback in which a part of the output is fed back to the input via feedback circuit. It should satisfy Barkhausen criterion A beta equal to 1, where A is the amplifier gain and beta is the feedback gain. Barkhausen criterion or conditions for oscillations. The circuit will oscillate when two conditions called Barkhausen criteria are met. These two conditions are the loop gain must be unity or greater. The feedback signal sending back at the input must be phase shifted by 360 degree, which is the same as 0 degree. In most of the phase shifted circuits, an additional 180 degree phase shift is provided by the feedback network. FET, field effect transistor. FET is a device that relies on the electric field to control the shape of the channel, therefore on the conduction of the channel, hence referred to as field effect transistor. FET is a unipolar transistor that involves only one type of charge carrier in its operation. Example in JFET, the current flowing through the channel between drain and source is controlled by voltage applied to the gate terminals, which is reverse biased. What is fan-in and fan-out? The fan-in is the number of inputs that can be connected to a logic gate. Fan-out is the number of units that can be connected to the output of a logic gate. CMOS has the highest fan-out among the given logic families. Comparison of TTL, ECL and CMOS logic families. Fan-in. For TTL it is 12 to 14. For ECL and CMOS it is greater than 10. Fan-out. For TTL it is 10, for ECL it is 25 and for CMOS it is 50. That is fan-out is highest for CMOS. Power dissipation in milliwatt. For TTL it is 10, for ECL it is 175. For CMOS it is 0.001. Noise margin. For TTL it is 0.5 volt, for ECL it is 0.16 volt and for CMOS it is 1.5 volt. That is for CMOS, noise margin is highest and for ECL the noise margin is lowest. Propagation delay in nanosecond. TTL it is 10, for ECL it is less than 3 and for CMOS it is 50. That is propagation delay is highest in CMOS and lowest in ECL. Noise immunity is very good for TTL and good for ECL and in CMOS it is excellent. 31. Type of oscillator and approximate frequency range. Crystal oscillator, it has fixed frequency. Tickler feedback oscillator, nearly fixed frequency. Wien-Bridge oscillator, 1 Hz to 1 MHz is the approximate frequency range. Phase shift oscillator, approximate frequency range is 1 Hz to 10 MHz. Hartley and oscillator and Colpitz's oscillator, approximate frequency range is 10 kHz to 100 MHz. Thank you.